All right, lesson 27. We are going to solve problems involving fraction division. So let's take a look here. Kevin ordered 4 pizzas for his birthday party. The pizzas were cut into eighths. How many slices were there? Draw a picture to support your response. We're trying to find out how many slices there were, and we're going to have to draw a picture. So first of all, we know that there are 4 pizzas, and they're cut into fractional units of eighths. So let's draw a tape diagram. We have our 4 pizzas. Hopefully everybody can see that there's 4 whole pizzas right there, right? 1, 2, 3, 4. What we're going to do now is each pizza, we're just going to cut into 8 parts. So we need 7 lines in each one. So 1 in the middle and then 3 on each side of that middle. 1, 2, 3, 1, 2, 3. So that's going to give us 1, 2, 3, 4, 5, 6, 7 eighths, right? So let's do the same thing. Remember, second pizza, we're going to take 1 in the middle and then 3, 1, 2, 3 on each side of that middle. 1, 2, 3. 1 in the middle, 1, 2, 3, 1, 2, 3. 7 lines will give me 8 parts. That's why I'm saying 1 in the middle and 1, 2, 3, 1, 2, 3. Now they're not perfect, but that'll do. We already counted that first eighths. That's 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So we know that there would be 32 slices. And we could do the same thing on the number line. We would just draw it out, and each one of these red lines here, let's change back to our red. Each red line would be our whole pizza. And I'm not going to count them all. Let's go ahead and skip count. We know that this would be 0 eighths. 1 whole would be 8 eighths. Skip count by 8, that would be 16 eighths for 2 wholes. We keep skip counting, that would be 24 eighths. And finally, our fourth pizza would be 32 eighths. And of course, each one of these would have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It would be 8 eighths to make it to 1 whole. So that's 1 eighth, 2 eighths, 3 eighths, 4 eighths, 5 eighths, 6 eighths, 7 eighths, 8 eighths, all the way throughout. So we know that we have 4 pizzas divided by 1 eighth is equal to, remember we talked about doing our inverse operation. The opposite of division is multiplication, and the reciprocal 1 eighth, if we reciprocate that, flip it upside down, our numerator and denominator change places, we get 8 wholes. So we say that's equal to 4 times 8 over 1, which is equal to 32 over 1, which is 32. There would be 32 slices. All right, let's take a look at number 2 here. So Virgil has 1/6 of a birthday cake left over. He wants to share the leftover cake with 3 friends. So we know we have 1/6 of the cake, and it's being shared evenly by 3 friends. It says, what fraction of the original cake will each of the 4 people receive? So it's Virgil and his 3 friends. Don't get confused. We're not dividing by 3. We're dividing by 4 because it's Virgil and his 3 friends. And it says support your answer with a picture. Something I didn't mention that we mentioned in class, I just want to bring it back up. We know that we started with 4 wholes. So we had 4 divided by 1 eighth. So we had a whole number divided by a fractional or a fraction or a unit fraction. We know that our number is going to be, or our quotient is going to be a whole number. Now, in the opposite fashion here, we have 1/6 divided by 4. So we know that this is going to be a fraction. Let's take a look here. So remember, he doesn't have a whole cake. He has 1/6 of a cake. So if this was our whole cake, he has 1/6 of it. So we need 5 lines to give us 6 parts. 1, 2, 3, 4, 5. He has 1/6 of a cake. So that's how much cake Virgil's starting with. He's not starting with the whole cake. He has 1/6 of the cake left over. Now he's going to split that with himself and 3 friends. So let's go ahead and put that into 4 parts. We have 1, 2, 3 lines, gives us 4 parts. 1, 2, 3, 4. Now, to find our new fractional units, we would have to divide the entire cake, even though we don't have it, just so we can find out what our fractional unit is going to be. Let's go ahead and do that. I'm going to push pause here just to put these lines in. And if you notice, on each 6 of the cake, I divided it into 4 parts. So we're saying that we had 1/6 here is equal to 1, 2, 3, 4. Let's write that down. 1/6 is equal to 1, 2, 3, 4 out of how many total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So 1/6 is equal to 4 24ths. We're trying to divide 4 24ths divided by 4 is equal to 1 24th. That's my 1 24th right there. And of course, each person gets 1 24th of the original cake because he only had 1/6 remaining, which is equal to 4 24ths. They split it by 4 people, and each person would get 1 24th. Take a look at number 3 here. All right. So a pitcher of water contains 1/4 liters of water. The water is poured equally into 5 glasses. The question that we're going to answer first is, how many liters of water are there in each glass? So here's the first part of my picture to support my response. I have my whole liter, but remember, we only have 1/4 of a liter. So here's our fourth. That's 1 out of 1, 2, 3, 4. 1 out of 4 is 1/4. So now it's going to be split equally into 5 glasses. Let's go ahead and represent our 5 glasses. We have 4 lines will give us 5 parts. 1, 2, 3, 4. So now we're trying to solve to find out how much this is right here. So before we can say what this is equal to, we have to find out the equivalent fraction for this right here. We know that 1/4 is equal to 1, 2, 3, 4, 5 watts. So we could do our multiplication and say, well, 1 times 5 is 5. So 4 times 5 is 20. Also, we could draw our 4 lines in each of the additional fourths. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So now we have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's how we know that 5/20 is equal to 1/4. So now we say, well, if we have 5/20 and we're dividing it by 5, we know that it's going to be equal to 1/20, which is this part right here. 1/20 of a liter of water is going to be in each glass. All right, so once again, 1/20 a liter will be in each glass. Let's take a look at B here. It says, write the amount of water in each glass in milliliters. So we're going to use our 3S, which is to separate, substitute, and solve. Let's go ahead and do that. So we know that we're trying to find out how many milliliters are equal to 1/20 of a liter. So first thing we need to do is separate these two here. So we're going to say that this is equal to 1/20 times 1 liter. 1/20 of a liter is equal to 1/20 times 1 liter. Now we're going to substitute. Wherever we see 1 liter, we know that 1 liter, and you can use your conversion chart for this, but you know that 1 liter, I'm going to use my letter L for my liter, is equal to 1,000 milliliters. So wherever we see 1 liter, we're going to substitute in 1,000 milliliters. So we have 1/20 times 1,000 milliliters. And now we're going to go ahead and multiply. So we have 1/20 times 1,000 over 20 milliliters And when we multiply that, well, we can say, well, before we multiply, 20 is divisible by 20. Finding my greatest common factor to use cross cancellation. 20 divided by 20 is 1, and 1,000 divided by 20. If you don't know what 1,000 divided by 20, think of this as 100 tens. 100 divided by 20 would be 5. So then 1,000 divided by 20 is 50. And I know 50 times 1 is 50. Divided by 1 is still 50. So this would be, my answer here would be 50 milliliters. All right, last but not least, let's look at number 4 here. We have our final word problem, and it does have 2 parts similar to our last problem. Drew has 4 pieces of rope measuring 1 meter long each. So if he has 4 pieces of rope, 1 meter long each, he cuts each rope into fifths. So how many fifths will he have after cutting all of his ropes? So let's take a look. So we have, how many pieces of rope do we have? 4. All right, so there's my 4 pieces of rope. And you can see that this would be 1, 2, 3, 4. We'll call that our 4 pieces of rope. And then each piece of rope he cut into fifths. So we're going to divide each piece into 5 by making 4 lines. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. Now those fifths aren't perfect, but they'll work for us. All we need to find out is how many pieces he has, and we're going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We know that he will have 20 pieces of rope. It says how many fifths will he have, so he will have 20 fifths. All right, and if you wanted to see that on a number line, we know that this would be our 0 point. That would be 1. That would be 2. That would be 3. And that would be 4. That's the each one of those tick marks on this number line represents 1 piece of rope or 1 meter of rope. All right. So, and then he's just cutting it same like we did with the tape diagram. 4 tick marks in between each piece to give us our 5 pieces within each meter. And we can use our fractions and say, well, this would be 0 fifths. This is the first 5 pieces that he cut would be 5 fifths. The second 5 would be 10 fifths. Then it would be 15 fifths and 20 fifths. And of course, in between each one, I'm not going to number them all, but that would be 1 fifth, 2 fifths, 3 fifths, 4 fifths, and all the way up 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 fifths. All right, so now it says, how long will each of the fifths be in centimeters? So now we're converting from our meters to centimeters. And we know that 1 meter equals 100 centimeters. And that's on your conversion chart. So let's take a look. Another way we could have looked at that is he had 4 pieces and he divided the 4 pieces into fifths. How many fifths would he have? We say using our inverse operation, multiply, using our reciprocal fraction, 5 wholes, and that's equal to 20. And of course, the answer was 20 fifths. All right, so we know that he had 20 fifths, and we're trying to find out how much each fifth would be. So we take 1/5 of a meter is equal to blank centimeters. And we're going to just do our 3s. First, we're going to separate. Let's see, that's equal to 1/5 times 1 meter. Then we're going to substitute. It's equal to 1/5 times, instead of meter, we're going to substitute in our centimeters, 100 centimeters. And then we're going to solve by doing our multiplication. 1 times 100 divided by 5. We can use our cross cancellation and say that 5 goes into 5. 5 divided by 5 is 1, and 100 divided by 5 is 20. So that's going to be equal to 20 centimeters. All right, hopefully this was helpful. We are coming up on our unit assessment very soon. This is lesson 27. I think this module finishes up with lesson 33. So about a week away, a little over a week away before we take our module assessment. Let's make sure that we are preparing by finishing our homework and making sure that we understand our homework. Looking forward to tomorrow's lesson. Thank you for checking out the video. Like and subscribe if you haven't already.